Okay, everybody. So for this lecture, I'm going to give you a little bit more code in a little bit. We will be going over the stuff I'm going to show you in the code example again later on. But I always think it's a little bit unsatisfying if I just show you enough code to confuse you, but not enough to show you something actually working. So I wanted to show you enough code so that you can see something being written to the database and something reading from the database, so you can see the whole thing. Again, don't worry, it's something I will cover again. So the other thing I want to talk about today, again, this is something which people found a little tricky last year. There are slight differences between when you're using a database, when you're using a sort of NoSQL database like this. And the main one is how objects refer to one another, which I've sort of been talking about, how they refer to each other by name. Normally in computing in a running program, all the data that you have for that program is in memory, and objects point to each other. So in something like C++, there's actually a pointer, you can get the number out, and it's a memory address. In Java, that's sort of slightly hidden from you, but every time you have a variable type whose type is a class, you're implicitly pointing to a bit of memory that stores that class. And you have to deal with things slightly differently when you're saving stuff out to disk. So I'll talk a little bit about that, and I'll talk a little bit about some of the structures that you can make with the database. I'm a big fan of the NoSQL database. It's relatively simple. There's quite a bit of code in the zips that you download. Most of that code we don't use at all. All of that code is actually to build a regular SQL database on top of what's called MVStore, which is basically what we're using. So MVStore, which I'll talk about in a bit more detail, is just an incredibly fast, incredibly minimal way of storing information to disk. And it's the invention of algorithms that are like the ones that MVStore are based on that enable these NoSQL databases. But I don't want to get too ahead of myself. So hopefully you saw I put this up. I'll email this around at the same time. Hopefully I won't forget that I send around the videos when the videos have been uploaded. But yeah, please fill us in. Please pass on things you like about the course and things that you'd like changed. If there are things you don't like, it's always useful if you can suggest alternatives. Okay, I can't guarantee I can provide them, but it's much more useful if there's something you would prefer was done a different way, then please suggest alternatives. Okay. So we didn't go through all the stuff that was in the last lecture, and one of the reasons for that is that I'm more aware this year of the difficulties associated with the code. So I wanted to just focus on the code things completely. There's a few other points there later on which we'll refer back to, if not in this lecture, then later lectures. They're not so critical for the labs, so don't worry about that. But the core thing we were doing in the earlier lecture today was going through this lab floor and seeing how you can use a form to pass information. So I tend to think of it as being like a function call, right? The way you're making this web app is like you're making an application. And whenever you submit a form, whatever the URL address is that you're requesting, so basically the action. Yeah, it was right. You can double check. But the URL that you're requesting when you press the button for the form, that's like the function name. And the parameters to that function are like the input fields that you've described. And then you can add an if then in your dynamic page that responds to that particular URL. And then you can grab out the parameters that were passed through, and then you can do something. And the main thing that everybody's pages should do is create an object and add it to the database. Okay, and what we'll be showing in a moment is how to actually do that. But before then, we'll just have a quick look at this. So there's different ways, obviously, you can make applications, but one thing that's quite important about applications is the data that they store. So almost all computer programs can be thought of as taking something in the world and making a sort of simplified representation of that thing, storing that information somewhere, and then the rest of the application is sort of giving you an interface to look at that data or change that data in some way. Okay, so in this particular case, a lot of what good programming is about realizing what your product is about. So is it about news stories? Is it about medical conditions? Is it about animals? Is it about life events? Whatever it happens to be. Splitting those things into relatively simple representations of those things that link together in some way. So if you're doing the ecosystem, for example, you might have an object for each for an animal. So you have one object that stores information about an animal. You might have one object that stores like a biome or a part of the world where the animal might be found. You might have another object that represents a plant, if you're talking about an ecosystem. So everything that your web app is about, you should typically have a class associated with that. And that class should sort of make sense to you. And one of the things that you will get credit for in this course is how sophisticated the structures you make out of those things are. Okay, so the simplest version is that you just have a web page with a form, and you fill in information, and you create one object, and your page can use that object. Okay, so something like if you just had comments without threads or something like that. So you just had a suggestions page on your website, for example, and people could just make a suggestion, submit it, and it went to the web page, and that was it. Okay. As you start to do more complicated things, so the example that I was showing you is a slightly more complicated one, where you have news events, and news events have multiple stories associated with them. You're starting to make a more sophisticated application that can represent more sophisticated things. The more sophisticated your structure, typically, the more useful functionality you can add to it. So, for example, if we had also made a class for journalists, and given whenever the form was being filled in about a news story, we had a sort of drop-down list where we could pick from a selection of existing journalists or create a new one if it didn't already exist, and therefore link this story to a particular journalist. We can now have a web page where we saw all the different news stories that were written by particular journalists. And that might be a really valuable feature for the website. So generally speaking, the sophistication of the structure of the data is a big contributing factor to how sophisticated the application itself can be. Another thing to bear in mind with this is you want it to be understandable. Okay, so one of the mistakes that sort of early programmers often make is that they will sort of take the examples that I've used here and blindly copy like the variable names, for example. So you want to make a deliberate choice about what you want to store and what names to give them and things like this. So, for example, if your website is about animals and you have things that are called news events, then that's not going to be very impressive because it shows you sort of you don't quite understand what you have the freedom to change and what are keywords in Java, for example. Okay, so a big, it's a subtle skill to be able to represent information in a simple way, and you can very easily make very, very complicated structures that are very hard to maintain. So it's something you really need to concentrate on. So I've already demonstrated in other lectures how you can create models to create these Java classes. There's a link on the web app. and you just give it a Java class name, and you end up with a class. And its only detail is that it implements serializable, and then you just put some public members into that. So I know there is a culture within Java of wrapping everything with a getter and a setter and things like this. And there's a community of people who feel very strongly about that. You can do that sort of thing if you want to, but it doesn't actually make your application any simpler. It just makes a bunch of people who care about that feel good about themselves. Anyway, so this is an example with the news story. It's slightly older now. It's got that smart serializable thing. Don't worry about that. It should be going this year. So you can update the model just like you'd update a dynamic page. So when you go to the models field, you'll see a whole list of whatever models have been created for the class. Broken models are a common kind of error that teammates who aren't so technically skilled can be involved with. So do be careful that you don't break the whole web up. In fact, one of the things I would kind of recommend is that you submit your updates in the labs. So it's one of the reasons why attending the labs is important, is so that you're all together and you can check everything, and one person doesn't break the project repeatedly by putting stuff in late at night or things like that. Okay. In some companies, they take breaking the build, it's called, incredibly seriously. It's not something I really approve of, but it is something to be aware of. In one of the games companies that thankfully I didn't work for, they set up a siren that went off with flashing light and siren every time the build was broken, and then they would highlight who had done it. So don't do things like that, right? That's a horrible, toxic working environment that you never want to be a part of. But bear in mind that in some environments, that is taken very seriously. So please make sure that when you're submitting code, that it does actually run before you go away, okay? So I mentioned this briefly. Again, this is an idea that is perhaps something you're not quite ready for in most cases, but I will keep repeating it because it's an important idea. What makes you a craftsperson in software development has a lot to do with your ability to look at some part of the world and express that simply and in a formal way. So like the example I was giving with the ecosystems, identifying each of the parts of information and just describing what is necessary to represent it. And it's a little bit similar to the task of coming up with a logo. You're just saying, what is the simplest set of things I can use to describe this thing? And often, particularly if you're making a complicated computer program, thinking about things from the data first is a very valuable way of thinking about things and a way of simplifying how things work. As you develop software, and perhaps even in the course of this project, your code may eventually become too complicated, will become quite complicated. And you'll hit this thing that one of my mentors once referred to as, you'll start to treat it, sort of feel magical about it. So it'll feel like some kind of weird ritual that you're doing. So situations like this might occur if you have complicated HTML and parts of it don't quite line up. So you start tweaking things and commenting out lines and seeing if it works. So you're sort of treating it like some kind of alchemy. You don't properly feel control and understanding it. So beyond just learning Java syntax and things like this, your biggest enemy is complexity. And basically representing things in a simple way, a tidy way, that ultimately determines how complicated a thing you can make. And organizations that don't manage that complexity of the data they store, complexity of the functions they write, they're just enormously limited in what they can make. And those that are very good at handling it can create incredibly intricate and sophisticated systems that they can still maintain, like high-end game engines, for example. Okay, so this course uses a thing called NoSQL database. One of the reasons for that is because they're kind of new, well, relatively new and trendy, but they also represent a fundamental in some ways, a more sophisticated way of thinking about data. So many of you probably encountered spreadsheets. Some of you will have done some work with SQL databases in the past. And one of the things about traditional databases is that they basically have a set of fixed length rows. That's the heart of how they're designed and how they're efficient. So on the right is an example of a kind of definition of a table in SQL. And you'll see there that one of the things you typically specify is the length of the elements that you put in things. So anytime you go to a web app or an application and your username is only a certain length, or your comments field have to be less than 255 characters or something like that, that's because behind it somebody has made an SQL database and they probably set the number too low in terms of how many letters you can put in things. Okay, so that's kind of the heart of traditional databases, right? And they're stored on disk a little bit like this. So the information is stored consecutively, and because they are fixed length, you can very efficiently access one of the elements. So typically you'll have an index, so you'll have one column which is unique, associated with every row. It's kind of like a unique ID or unique name of every row in the table. And it can very efficiently associate whatever that unique ID is to a particular number, and then it's just an offset in the storage on disk, and it can give you that row back. Okay. So in the early days of database creation, that was necessary in order for it to be efficient. The downside of it was that the kinds of information that you stored, you had to be quite prescriptive about what you were storing. So you sort of said, well, everybody needs to write down all of these pieces of information, and all of these pieces of information need to be quite short, and that's the kind of information that we deal with. NoSQL databases came about because people wanted to treat things like a Word document or a book or something like that as if that was a row in the database. We wanted to be able to process things that didn't really fit this model at all, the sort of fixed, short, fixed length row entries. Okay. So at the heart of NoSQL databases, they basically have this, the more flexibility in NoSQL database. So now NoSQL database at its heart is a really efficient way of going from a key to some variable sized block on disk. So things no longer have to have uniform format and a uniform length. And it took a while before people developed algorithms that could do this very efficiently, and operating systems could support the operations to enable them to do this very efficiently and be able to change entries and change the size of an entry and not have it sort of interfere with the other entries and things like that. And something like MVStore, which is a really good example of this, does this incredibly fast. And it does it so quickly, in fact, that you can write a sort of real-time sort of game-like update, and you can read and write from an MVStore database almost as if it was in memory. The caching and the speed with which you can edit and access these fields is incredible. And what this means in practice is that you don't really need to worry about forcing your data into that fixed length table-like structure anymore. And one of the reasons I particularly like it, and one of the reasons it's used for this course, is what we're trying to do with this course is give you more Java experience. We want you to spend most of your time thinking in your mind about Java classes, Java variables, Java programming. And so what NoSQL databases enable you to do is to not have this separation between the structure of the data that you store on disk and the structure of the data that you use as the program is running. So if you know how to write a computer program with objects that store data at runtime, you don't need to treat them any differently when you want to store them permanently have them on disk. And because of the way MVStore works as well, you can have absolutely massive number of records. So you can have terabytes and terabytes of data, and you can access it and read it and write it, and largely treat it as if you almost had infinite memory on the machine, which is amazing. So the core change that you have to make in your thinking between just treating everything as if it was a regular Java program and having a program that you can store things to disk is to do with how you refer to other objects. Okay? So here we go. So if you were just making a program that ran in memory in Java, then you could do things like the sort of three examples over here. So if it was just running in memory, you would have a member or news story that would have maybe a type of journo or journalist, or whatever you like. And if two news stories referred to the same journalist, they would just point to the same bit of memory. They would be just references to the same object. Okay. The problem with that is if you then send news story to be saved on disk, what does MVStore do? Well, MVStore can't guarantee that this object is in memory. Okay, so the whole point of having the database is so that you can have terabytes of information that you don't have the memory to store. So what happens is it will make multiple copies of this every time you save to disk. So this structure on the left will turn into this structure on the right. So if you load in the news story from the disk, you will get the news story and you will get this journal thing as well. And that entry on disk will store both pieces of information together. And this is a problem then if some later on point in your application you were to modify information about a journalist. Because only one record would be updated and the other one wouldn't. Okay. So the way to get around that is that you need to be more aware of whether something is loaded on disk or loaded into memory. And you need to do it explicitly. So instead of having a class, like a public class journalist that points to a class, instead you store a unique ID for the object. And it's not automatically loaded from disk. When you come to want to access information, say about the journalist, then you explicitly load it from disk in order to access it and change it. So if you then change it at some point and save it back to the MVStore, any other code that happens to read from it will always be modifying the single copy of that information. Okay, so when you see an example of my code, and I will repeatedly talk about this, it will always use strings as IDs. MVStore in theory can use any sequence of bytes as IDs, but you might as well use strings because they're easy to deal with. That's a way of interacting with things is the way to use the database effectively. Okay, so let's look at a real example. So we'll continue on from where we were in the morning. Okay, so where we were last time, we had a model for news events, and the news events had this array list of stories, and rather than them actually being news story objects, they're strings. They're the names of the news stories. Okay, and we have an object for news stories, which in this case as well has an array list for journalists. So really I should have a model here for journalists and potentially lots of other things as well. But again, you see that it's using the name of the object rather than a class as you would tend to use in code. Okay, and then we have a look at the updated dynamic page. So in the previous one, I'm going to have to zoom out for this. Okay, so in the previous one, you can see, in the previous one, we made a sort of fake news event here. But in this updated one, we're not doing that. Okay, because in the updated one, we're actually going to take the news events from the database. So I mentioned before in SQL, they have things called tables.
and that's the thing that stores pieces of information. In MVStore, they have something called an MV map. Okay, so in Java, there are things called maps, hash maps, and they basically, they're a bit like an array, but instead you would pass in a key and get a value back. So the reason it's called MV map is that its interface is almost exactly the same as a hash map that you have in Java. So you give it a key, which is the unique name of the object, and you get something back. So MVStore is relatively easy to use. You just say that you want a map of some type. So they all have all the elements in it have the same type, and they have a key of the string. And you just have db.s.openMap. Okay, so that's the extra code that you need associated with the web server, and you give it a name. Okay, so every map of particular things, you can give it a name. So I typically, by default, will just call my maps whatever the class name is, and then an S on the end. Another thing to bear in mind, so one thing that happened last year was some people who were less experienced with programming, they sort of made a bit of a mess because multiple members of their team would create multiple maps, all with the same name. And it would cause various problems. So if somebody else on your team has created something called, I don't know, news comment or something, and they happen to call the map news events the same as you, then there will be one map on disk, and whoever was called first, that'll be the type that's stored on disk. So whenever you try to open the map with the name news events, but giving it a different type, MVStore will complain. It will say, this map doesn't have this type. When it was saved, when it was originally created, it didn't have that type, and it will cause an error. So make sure amongst your teammates that they're not all using something like news events. And don't call them news events either. Call them something meaningful associated with the types that you use in your project. Okay. But anytime you want to access a table, that's basically the kind of line that you write. And if that table doesn't already exist in the database, it will be created at that point very efficiently as well. Now, what you can do with any map is that you can get a big list of its keys. So that's what's happening here. So this is a list of every unique name associated with every event in the database. Now you can do more complicated things. Some people did more complicated things later on where you explicitly try to access these keys in alphabetical order and timestamp order, and there's various other more complicated things that you can do, but this is sort of the simplest way of doing it. So what we're trying to do here is just loop through every event and print out or make a part of the page associated with every event. Now, there's a bit of hacky code in here, and the bit of the hacky code is to say, if this is the first time you've run this program, you don't have any news events in the list. So for the purposes of debugging, just create a fake news event and stick it in the table. So what this is saying is if there's no keys in the database already, just make a new one and give it whatever the title is and add it to the database. Okay? So these two lines are all it takes to add something to the database. You take the map that you've opened, you call put on it, which again is the same interface you would use if you had a hash map, which is a very useful object in general, and you pass in the key, and you pass in the object. So all these objects store their keys on them. That's another good habit to get into when you're doing these things. Now, any changes you make to MVStore will not be written to disk until you call db.commit. So the idea of this is that you can make lots of changes that you want to the database, but only when you call this will all of those changes simultaneously be written to disk. Now, if halfway through that write, the power gets pulled out, you won't get a corrupted database. This db.commit guarantees that as far as the saved version on disk occurs, all these changes occur in one go, which is called an atomic transaction, and is saves a lot of pain, basically. Okay, and then the next step here is just saying, because we've updated the list of keys, we need to get it again. Okay. So once you have a list, you can use standard Java code for looping through a list. In this case, we're going to go through the list using an index that starts at 0, carries on until it's got all the elements in it. And we're just using .get on the list, and that will give you whatever the unique ID of the next event is. Okay, so we've got the list of keys, and we can do this, right? Once we've got a unique ID for the news event, we can get any object we've stored in the map just using .get and the unique ID. Okay, so news events is just that map we've opened up here, and .get with the unique ID will give us a Java object. And then we can use that Java object like we did in the previous code. So we use that to give it a title. And these news events also have variable size, so they can have a variable list of news stories associated with them. No problem. And again, that's an array list. It's basically a list. So we use almost exactly the same idea of iterating through all the stories associated with the news event and getting their unique ID out. And then we open a map which contains all the news stories, and we can actually get the story out. So all of this stuff is showing you how to read and write to the database. Okay? So we can now read the entry from the database. And it does the same thing that it did before. It will stick the information up for that. Okay? And then we've got the old code that I was showing this morning to do with the form. Okay. Now the other change that's occurred is that now in the code for processing the form, we actually put the information in the database. So the form is there for writing about a news story. So like the Sun has written something about the news event. So this is creating a new news story object. It's opening the news stories map, the table associated with all those entries, and putting that new record into it. Then it's opening up the map to do with news events. So this is a news story about a particular news event. And we use that trick with the hidden input field in the form to pass through what news event we were actually dealing with. So this time you can see here we're using the news event's unique ID. We're passing through that thing in the hidden field of the form. That means we can get that object back again from the database, and we can add to its stories list to say this story is part of this news event. And because we're dealing with strings here, we don't have to worry about this issue of saving to disk. Everything is a self-contained object that refers to these other things. Okay, and then, so that's updating the object itself. Whenever you update the object, to actually get the database to know the changes that you've made, you have to call put. So you're basically telling this table, I've changed this object, so please update it. And then once you've made all the changes that you want to make, you call db.commit, and that will write the changes to disk. Okay? So what does that actually look like? Oh, sorry. Okay. So I will just refresh the page. Okay, now it's got this picture in it because it's from a slightly older version where I still had a picture in it. I removed the picture previously because there was a problem with the internet connection, so the picture wasn't loading. Okay, but if you run it from scratch, that bit of code adds this news event, this sort of hacky one in the code for testing purposes, and then we have this form at the bottom. So we can say something like, I love him, as the story about Donald Trump, and you know, he has great hair, something like that. And we can, okay, and then we can add the story. And what you see here is the page is reloaded. And that's because we had this redirect code, which I'll show you again. Okay, so we had this bit of code here that tells the web browser to redirect back to the same page we were at. Okay, and then if we scroll down, we'll see that we now have this entry. Okay, and if I stop the program running, and then I run it again, okay, and refresh the page, you'll see that this is still here. Okay, so what that means is that we've written to the database, it's been written to disk, even though the program has been stopped and started again, the database is still storing that information, and the website is, in a minimal sense, working. And you can keep adding as many as you like. For some reason, I always call things Frank and Barry whenever I'm making something random. And so you can just keep adding to it, and it'll keep working. Okay? So if you replicate something like this, you have covered all of the key functional elements that you are required to do for the web app. Okay? So anything you develop on top of that is extra, is showing extra capability, extra sophistication with developing software. So pretty much, I think almost everyone last year, if you'd managed to get this far, you will have got at least a 2-2, because you've demonstrated the core functionality that you're being asked to produce. Okay? Like I say, I will go over some of this stuff again if, so this is not the only time we're going to talk about it. So I'll just, yeah, I'll talk about these things a little bit more. Okay, so one of the things I was mentioning is one of the ways that you can demonstrate the sophistication of your project is how sophisticated the structure you store to disk is. So we showed there an example with one object that was referring to many examples of another object, so a news event with many news stories that were a part of it. And so this idea that a list of elements associated with something is kind of the first level of complexity that you can have in these things. So whenever you have something structured like that, you typically have two kinds of pages. You have one page where you submit news events, and you have another page where you're reviewing news events, and then you were adding to each of the news events the news stories. Okay, so that's typically how that's implemented in projects. Something that's more sophisticated than that is a graph. So that's a mathematical graph, a set of objects that point to one another. So the situation there where you had news events with news stories as part of it, and then if you also add the journalist to that as well, so the news stories point to journalists. So you can imagine sort of a web of connections there. One journalist points to many news stories point to a journalist. That is sort of all connected. This is a more complicated structure. So typically what you need to do in that sort of situation is that when you're creating an object, like a news story, then you would have some kind of drop-down list or some kind of way of selecting from an existing set of objects that are included. The other way that you can do it is you can split it into two stages. One stage is where you have the news story or news event that you're adding. And then if you have properties associated with it, like the journalist case, you can look at the news story itself, and then you can link the two things together. But typically in those situations, you still need to end up having like a drop-down list of existing objects in the database that you're selecting between in order to make those connections between the two things. And I think I will show an example of that later on in the course. But if you are interested, come and talk to me. So, for example, if you've done the, you're doing the Choose Your Adventure stories, to implement that properly, you basically need a way of linking between the individual parts of the story. And assuming your stories are really trivially straightforward, you will need a way of pointing to the other pages in order to make the structure of the story. And if you're feeling really ambitious, you can try and visualize those structures in fancy ways using something like SVG. And if any of you want to do any of these more advanced things, please just come and talk to me and I can give you individual advice and help for that. There's other things which happen. So the web app, for example, has a structure which is like a tree, which is really like, it's kind of like a graph, but has some restrictions on it. You end up implementing that in the same kind of way. It may have had an added level of complexity where you need to validate that when you're adding things together, you're not breaking the rules of the tree. So you're making sure that you're not pointing to something that's apparent to where you currently are. That again is an extra, a further level of complexity. Okay, but like I say, whatever your interests are, whatever your desires are for the project, if you're really passionate about it, I'm here to help you to try and realize whatever you want to make. Okay, so what I'm showing you there is the core, the foundation of all the projects. There are a bunch of things that we will go through, like login systems and search features and things like that. These are all nice to have things, but this is the heart of what the project is about. So hopefully you've seen enough of an example here to sort of see how the course is designed, where you go through the labs and the labs take you through making these core elements, and then you're sort of free to go and build using that knowledge exactly the application that you want. Okay, so what is important, particularly for those of you who are ambitious and want to get the best marks, is how you bring this together to create a coherent project. Okay, so you need to not just work in isolation, but ensure that for example, your pages are linked together and they have a uniform appearance, and the whole website kind of makes sense. Okay. So the intention of this course is to encourage you to engage in iteration, iterative design, and iteration is a messy process. It doesn't consist of you having 1 week where you do design and then you never change the design all the way to the end. So one of the things that you need to do is to actually take the work of the lab that you've done this week and reduce some of it, take some of the stuff away. So in order to pass the lab, every team member needs to suggest a distinctive feature, for example, of the web app. If you have 4 distinctive features and they're meaty distinctive features, that's too unique an application for you feasibly to be able to polish and refine that. It's unlikely that you'd be able to do that. So the other thing is also you may have not been working together particularly coherently to come up with customers and end users. So for the purposes of this lab demonstrating we can engage in design, everybody is asked to come up with customer and end user. But to make a coherent, well-focused product, you want to narrow that down and as a group be clear about what you're trying to achieve and who you're trying to achieve it for. Okay? And potentially reduce the features that you're talking about and make sure that you can deliver on them and the whole system sort of makes sense as a product. One of the first things that you want to do is to put web links in all your pages so you can click between them. Okay? Being able to navigate between pages is sort of a minimum requirement. So you will barely get a third if you end up with static pages but no links between them. You want to, one of the reasons that I'm being particularly tough on making sure that people turn up in labs and people talk to each other in teams is because you really do need to discuss amongst yourselves and produce a kind of coherent group project. If you end up with some of the examples that I sort of showed in the previous example where you largely have a coherent website and you click on one link and you go to this typically template website straight from Pingendu, that's going to harm your marks quite badly if you're not actively part of a group. Okay? So that's basically us for today. There's a few useful links there, and I'll catch up with some of the other slides from the previous one later on.